So the question is, what is the mass of the benzoic acid which you dissolve in 350 milliliters of water to produce a solution with pH equal to 2.85? And we know the K value of this benzoic acid dissociation. Let's write down. So the benzoic acid is a weak acid. So you undergo weak hydrolysis to form the anions here and the proton or hydronium ions here. So we know the Ka of this reaction is 6.3 times 10 to minus 5. So the first thing is we want to know the concentration. What is the concentration of this benzoic acid? Leads to a pH equal to 2.85. We don't know that yet, so we can assume that the concentration of this benzoic acid is C. And then we can start making a ice table. So you have the initial, you have the C as a concentration of the benzoic acid. You don't have any anions or cations. And of course, once it dissolved in the water, there will be dissociation. So the benzoic acid will be consumed. Let's say about X mole concentration will be consumed. And in this case, we generate X mole cation or X mole anion and X mole proton. So in the end, the concentration of the benzoic acid will be C minus X. And the concentration of the C6H5COO minus would be X. And the concentration of proton will also be X. So the question tells us the pH is 2.85 when the equilibrium reaches. So once we know the pH, we actually can know the concentration of the proton or the hydronium, which is 10 to minus the pH, 10 to minus 2.85. So that's about 1.413 times 10 to minus 3. So that tells you, right, we know the X equals to the concentration of hydronium or proton. This number actually equals to the X. So that means you also know that the concentration of the C6H5, the anion, in the equilibrium state equal to X also equal to 1.413 times 10 to minus 3. And the concentration of the hydronium of the benzoic acid should be C minus X, which is C minus 1.413 times 10 to minus 3. And we can write down the expression of the equilibrium constant. That's the concentration of the proton times the concentration of the anion over the concentration of the benzoic acid. So that's equal to, in this case, 1.413 times 10 to minus 3 square over C over 1.413 times 10 to minus 3. That's equal to the KSP is given 6.3 times 10 to minus 5. So now we can try to do the calculations here. You'll find if we do the calculation, it's 1.99 phi times 10 to minus 6 equals to 6.3 times 10 to minus 5 C and minus 8.9 times 10 to minus 8. So in this case, you'll find 6.3 times 10 to minus 5 C equals to let's see, equals to about 2.084 times 10 to minus 6. So the C here equals to about 0.033 more. And this is the answer, right? We know the concentration now. And it says you have 350 milliliters of the solution. So we can calculate the moles of the benzoic acid equals to C times V. So that's 0.033 times 0.35. So that's about 0.01158 more. So the mass would be moles times more mass. So that's 0.01158 times the more mass here. So the more mass of the benzoic acid is it has 7 carbons, so it's 12 times 7. It has 6 hydrogen plus 6. It has 2 oxygen, so it's 16 times 2. So that's about so the answer would be about 1.412 grams. So you can see you can choose the C as the right answer. That's it.